Every drop of water counts, yet billions of gallons are wasted every day in households worldwide. From washing dishes to leftover rainwater, most of this resource simply flows away. But what if there was a simple way to capture, filter, and reuse that water using materials most people already have at home: tires, cement, and a blue barrel? Over several months, one experimenter documented their journey, testing and refining a DIY water recycling system. But here's the question. Is it really possible to recycle household water using just tires, cement, and a barrel? Or is this method more complicated than it seems? Let me know your answer in the comments below. Water scarcity affects millions globally. Governments, NGOs, and environmental agencies encourage water recycling as a method to conserve resources. Household water recycling typically involves capturing gray water from sinks, showers, or rainwater, then filtering it for reuse in gardening, cleaning, or flushing toilets. According to environmental reports, DIY water recycling systems can reduce household water consumption by up to 30% when properly constructed. However, unsafe or unfiltered systems can pose health risks if gray water is improperly handled. The experimenter documented each step with attention to safety, aiming to follow public guidelines and local regulations for non-potable water reuse. Step 1. Materials and setup. The system requires one large blue barrel, several used tires, cement for stabilization, basic filtration materials such as gravel, sand, and cloth. The first task was to clean and prepare each component. Tires were stacked and reinforced with cement to create a stable base for the barrel. The barrel was cleaned and inspected to ensure no contamination from prior use. Step 2. Constructing the filtration layers. Inside the barrel, multiple layers were installed to filter collected water. Bottom layer, coarse gravel for debris capture. Middle layer, fine sand for sediment filtration. Top layer, cloth or mesh to prevent large particles from entering. The experimenter documented water flow rates, clarity, and odor before and after passing through the system. Early tests showed significant reduction in visible debris. Step 3. Collecting graywater water from sinks and showers was directed through tubing into the barrel. Rainwater collection from rooftops was also tested. Each input source was monitored for flow volume and potential contamination. Logs included volume measurements, clarity, and any odor changes. Step 4. Observations and refinements. During testing, the experimenter noticed water clarity improved after 48 hours of settling sediment accumulated at the bottom layer and required periodic removal. Flow rates varied depending on water source and barrel height. Safety measures were strictly followed, including gloves, regular cleaning of filters, and preventing stagnant water buildup to avoid mosquito breeding. Step 5. Peer feedback and expert analysis. Environmental engineers reviewed the setup. They confirmed that the system could safely recycle non-potable water for gardening or cleaning purposes. Experts also emphasized regular filter maintenance is essential. DIY setups should never recycle water for drinking without proper treatment. Cement stabilization prevents tipping and increases durability. One perspective is that small-scale systems like this are highly effective for water conservation. Another perspective notes that improper maintenance can reduce efficiency or create hygiene risks. Initial water filtration produced visibly cleaner water, proving the system concept. Expert review highlighted maintenance schedules and safety guidelines. Peer experiments confirmed reproducibility of results under similar conditions. Adjustments to the tire base and filter layers optimized flow and reduced sediment accumulation. While graywater recycling is encouraged, it is subject to local building and environmental codes. Some regions require permits for collecting rainwater, or graywater DIY systems must comply with safety and sanitation guidelines. One interpretation is that small-scale, non-potable systems for personal use are generally permitted. Another perspective emphasizes risk if water comes into contact with food or potable sources. This is for informational purposes only and not legal advice. The experiment demonstrates that household water recycling is achievable using simple materials, careful construction, and proper maintenance. With tires, cement, and a barrel, wastewater can be filtered and reused safely for non-potable purposes. So here's the final question. Do you think DIY water recycling systems like this can genuinely save water, or are they too limited to make a meaningful difference? Share your thoughts in the comments below. It all started with a simple observation. In a single household, gallons of water are wasted every day, from washing dishes, to showering, to rain runoff. Most of this water simply disappears, drained away without a second thought. But one experimenter asked a question. Can we capture and recycle this water safely at home using just a few common materials? A blue barrel, some old tires, and cement? Over the course of 6 months, they documented every detail: construction, testing, filtration, and refinement. But here's the question. Is it really possible to recycle household water with such simple tools? Or does this process have hidden risks and limitations? Let me know your answer in the comments below. Water scarcity is a pressing global issue. According to the United Nations, over 2 billion people live in countries experiencing high water stress. Household water recycling is a practical solution that can reduce consumption by up to 30%, according to environmental studies. Greywater recycling involves collecting water from non-toilet sources, such as sinks, showers, and washing machines. Rainwater harvesting collects runoff from roofs. Both methods require proper filtration and safe handling to avoid contamination. Public records show that while commercial water recycling systems exist, they are often expensive or require permits. DIY systems, if carefully constructed and maintained, can provide substantial savings while remaining within legal guidelines. Day-by-day, month-by-month experiment, logs, month 1, planning and material collection, blue barrel sourced from local supplier, capacity 200 liters, 4 used tires collected for structural support, cement purchased for stabilizing tire stack. Filtration materials, gravel, 2 to 3 inches, sand, fine, and cloth mesh. Safety equipment, gloves, masks, goggles, and basic first aid kit. Observations, barrel cleanliness confirmed, no prior contamination. Tires inspected for cracks and sharp edges. Month 2, constructing base and barrel placement tires stacked in 2 layers, cement poured between layers to create stable base barrel secured atop tire base, leveled using water level tool. Tubing installed for greywater input from kitchen sink observations. Base stability confirmed. No movement when barrel filled with water. Flow rate test, approximately 5 liters minute without filtration. Expert comment, environmental engineer, confirmed tire cement base is safe for small-scale DIY water storage. Month 3, filtration layer assembly. Bottom layer, coarse gravel for debris capture, 3-4 inches. Middle layer, fine sand for sediment filtration, 4 to 5 inches. Top layer, cloth mesh to prevent large particles from entering barrel, tested with 10 liters of greywater from dishwashing. Results, sediment reduced by 80%. Water clarity improved, odor minimal, flow rate reduced to 3 liters ch minute due to filtration resistance. Month 4, greywater and rainwater collection. Greywater from bathroom and kitchen directed to barrel using PVC tubing. Rainwater harvested from rooftop, filtered through mesh before entering barrel daily logs. 15-20 liters collected from greywater, 5-10 liters from rainwater. Observations. Water clarity stable after 24 hours of settling minor sediment accumulation in bottom gravel layer. Scheduled removal every 7 days. Regular inspection prevented mosquito breeding. Legal insight. Local water codes generally allow small-scale greywater and rainwater collection for non-potable uses. Gardening, cleaning. Month 5. Performance refinements, adjusted sand to gravel ratio for faster filtration. Added secondary mesh layer for rainwater inputs. Flow rate optimized to 0.4 liters minute without reducing filtration efficiency, pH and turbidity tested. Results within safe range for gardening use. Peer review, hobbyists attempting similar setups reported variable success. Emphasized filter cleaning and regular maintenance as critical for efficiency. Month 6. Long-term maintenance and monitoring. Established weekly cleaning schedule for sediment removal, monitored water clarity, odor, and flow rate daily. Documented volume used for garden watering and cleaning. Results. Estimated 25% reduction in household water consumption. Filter layers remained effective for up to 3 months before replacement. Cement tire base remained structurally stable throughout testing period. Expert perspective. One interpretation. System is a low-cost, high-impact way to conserve water. Another perspective. Long-term maintenance is essential. Negligence could lead to contamination or blockages. Initial filtration proved system concept, water visibly cleaner and usable for non-potable applications. Expert review, validated safety measures and structural design. Peer testing confirmed reproducibility, highlighting the importance of precise layering and flow management. Refinements optimized flow rate, sediment capture, and usability for everyday household needs. DIY graywater recycling systems are generally legal for non-potable uses. If they comply with local building codes, industrial scale or potable water recycling requires permits and monitoring. One interpretation: small-scale household setups for garden and cleaning purposes are permissible. Another perspective: improper maintenance could violate hygiene or safety regulations. Disclaimer: this is for informational purposes only, not legal advice. This experiment demonstrates that household water recycling is achievable using common materials, careful construction, and ongoing maintenance. Using just tires, cement, and a blue barrel, wastewater can be safely filtered and reused for non-potable applications, reducing water consumption significantly. Final question: do you think DIY water recycling systems like this can genuinely conserve water in your home, or are they too limited to make a real difference? Share your thoughts in the comments below. For more verified DIY investigations, sustainable solutions, and educational experiments, subscribe and hit the notification bell to stay updated.